So this week we're going to be looking at motion. Motion we're particularly going to be looking at is scalars and vectors, distance and displacement. This first video will be focused on all of those. So here's the definitions of scalars and vectors. Notice a scalar, it says, is a quantity that is described by only a magnitude. That might be difficult because of quantity and magnitude. Quantity just means you have something. So if I have a unit, this is kilometers, that means I have a amount of kilometers. That's a distance, right? And then a magnitude is the number of them. So 10 kilometers means I have 10 of those kilometers. Right? That's a scalar. The difference then, we have vectors. It's still a quantity and a magnitude, so quantity, magnitude, but it has to have a direction. So with our proper SI units, I drove 10 kilometers south. So now I have quantity, magnitude, and direction. Let's take a look at an example of why vectors and scalars are so important in science, okay? So this morning I left my house. I traveled 10 miles south. But then I remembered I forgot my computer. So I traveled back that 10 miles north. But then I had to hurry and get all the way to school, so I traveled the 35 miles between my house and the school that is south. If you were going to ask me, okay, so what total distance did I travel when leaving my home this morning? I would have to add up everything. 10 miles plus 10 miles is 20 miles plus 35 is going to be 55 miles. So I would say, hey, my distance was 55 miles. That's my distance, right? That is the scalar value, 55 miles, okay? But that's not the distance from my house. If somebody really wanted to know the distance from my house, I would only tell them this last part over here, that my house or the school is 35 miles south of my house. So that would be my vector is 35 miles south. And that is my vector amount. This is what's so important in science, is your units and the values tell you different things about real life. So my scalar just tells me a sheer amount of travel, but my vector amount tells me the difference between two places. And so knowing the difference between these two things can help you understand a greater value. Notice also I have to have a number and a unit, and for a vector, a direction. So number, unit, those are in everything. And then direction separates vectors from scalars. So this slide just gives you a good idea of the things that are scalars and the things that are vectors. Some things can only be scalars because they don't have a direction. If you think about things like temperature, temperature doesn't have a direction. It's just an amount, just that magnitude. Time only goes forward. You're never going to have time going backwards, so time is also a scalar. Mass is another one, but that one's a little bit tricky because you think of it as weight. Weight actually has a direction down towards the earth. Mass is the amount of particles in you, really. So it doesn't. Vectors always have a direction. Now, distance and displacement are a scalar for distance and a vector for displacement. Distance is a measure of how far something has traveled, your total distance, right? So for me earlier, I'd traveled a total distance of 55 miles. When you think total distance, think about if you're walking along, you probably weave back and forth, but you would have to measure every little step to get your total distance. Displacement, on the other hand, it's more from how far you traveled from your origin. So for me, back in my example, I traveled only 35 miles south of my origin. Think more like a bird's flight. They don't have to go and weave in between all the obstacles, so they can usually go straight from one point to the other. It's also important to remember that word origin. That just helps you with displacement. It means where you started from, right? Okay, so let's look at some more examples of how distance and displacement work together. Okay, so here's a little example of distance and displacement that we can look at that gives you a better understanding. I lived a good bit of my life up in the mountains, and we went on all these different trails. The trails never looked like the displacement line here. They didn't look like that straight line. They looked more like this. It weaved up through the mountain around the side of things to get to a certain point. Now, with that, we can take a better look at how distance and displacement are both telling us something, but both are useful in their own way. Now, in the example it says, if you traveled 10 kilometers north, then turned and traveled 10 kilometers east, and then you turned and traveled 10 kilometers south, how much distance have I traveled, and what is my displacement? Well, that's hard to see just on this picture. So let's take a closer look. Here we go. Now we can make it a little bit more boxy. So in the description, it said that it traveled from its origin point, and I guess we better mark that as our origin point, right? We traveled 10 kilometers. Notice I always write the number and the unit, but then to make it a vector, because that's a scalar amount, we need that was to the north. And then it says that you traveled 10 kilometers. Notice again, even though I made a funny looking O, that it's 10 kilometers, but this one is now east. I'm just going to put an E for east. And then finally, you traveled 10 kilometers south. Well, if I'm looking at the total distance that you traveled, I have to go back and I have to add up all of these values, 10 kilometers plus 10 kilometers plus 10 kilometers. Notice that I can ignore the direction completely when I'm talking about distance, because if we want to know just the distance that you covered, like you might for a workout, if you're trying to see how many calories you burned, as a fat guy, I have to calculate those a lot, for the total distance that I traveled, then I'm just worried about each step of the journey. So I'm going to add those scalar values. 10 kilometers plus 10 kilometers plus 10 kilometers is going to be 30 kilometers, meaning the total distance I traveled, so my distance is equal to 30 kilometers. And that's the first answer that I have. And that's good for certain aspects of things. However, it doesn't really get to the point of where I ended up. Where I ended up, we have to look at where I started from and where I ended. And for that, you would just draw a straight line. And really, when we start to look at the scalar values or the vector values, if you travel 10 kilometers north and then 10 kilometers south, you basically traveled back down what you went up. So these two would cancel each other out when we're talking about displacement. So that means we wouldn't even worry about those two. And really what we traveled for our displacement is just that remainder that's left there, that 10 kilometers to the east. So from our origin point to our final point is just 10 kilometers east. And that is our displacement. And both are important for different things that you might use it for. Again, if I'm counting calories, you better believe I want to know my total distance. I don't care about my displacement. But if I'm trying to find my GPS location of the exact point I got to, I want to know my displacement, because there's probably a bunch of different routes to get to this. I could have taken all kinds of different things. I could have gone woo and gotten there. But I'm worried about where I ended up away from my origin, so I need that displacement value. So both are important, both give us different amounts of information, and both are used for different things. But it's why a scalar value is important, but it doesn't have direction. And a displacement value is also important and has direction. That should do it for this time.